I'm Anya.
And I'm Ethan.
And today we will be teaching you about
Raymond sums.
And the trapezoidal rule.
You can use a Riemann sum to estimate the area under a graph. There are three ways to do so, using RRAM, LRAM, and MRAM. We will be going into further detail soon.
So our first problem that we'll show you is with this graph, and it's a graph of a velocity function, and the function is right there. The question is asking us to find the distance that a car traveled in 4 minutes. And the way we'll do this is finding the area under this graph, because the area under a velocity graph is the distance traveled. So we'll take the area from 0 to 4 minutes. And the way we'll do that is by using Riemann sums, and it'll be an approximation. So we're going to use the left endpoints, or LRAM. So the first left endpoint of the graph is actually at 0, 0. So our first rectangle actually isn't there. It's just along the x-axis. Then we'll start with our second rectangle and draw a line from the graph going down. And this will be the left endpoint of our rectangle. So we'll draw a rectangle like this, going to number 2. Then our next left endpoint will be right here, and we'll draw a rectangle going down. Then the next left endpoint will be right here, where 3 is, and then connect it to 4. So we need to find the area of these rectangles to approximate the distance traveled in 4 minutes. So this will be an underestimate because we aren't accounting for the area here, here, or here. So the way we'll do this is simply by using the area of a rectangle, which this is 1. The width of each rectangle is 1. And then the first one is 10 because you use the height of the first rectangle and it goes up to 10. So it's 1 times 10, which equals 10. Second rectangle goes up to 20, so 1 times 20 equals 20. Next one goes up to 30, so you multiply it by 30 to get the area, 30. So we have the area of all 3 of our rectangles, so now we just add them up, which equals 60. So we know that the car traveled 60 miles in 4 minutes by using LRAM.
Just like you saw before, we are going to be using the same problem of finding the distance a car travels in 4 minutes. But this time we are going to be using RRAM. So to do so, we are going to be using the right endpoints of the graph. So we're going to start the point here because this is going to be our first right midpoint. And then we're going to be connecting it over to 0. And that's going to be our first rectangle. And then we're going to be using the next point, and we're going to draw a line all the way up, and that's going to be our next right endpoint. And then we're going to do another. So we will be approximating the distance by finding the area of each rectangle. As you can see, this is going to be an overestimate, unlike the LRAM where it was an underestimate. So to do so, we're going to be taking the width of each rectangle, which is 1 for all of them. So 1, 1, 1, 1, times the height of all the rectangles. So the first one's going to be 10. 1 times 10 equals 10. The second rectangle is 20. 1 times 20 equals 20. The third rectangle we have goes to 30. And the fourth rectangle goes to 40. By adding all of these together, we can find that the approximate distance traveled is 100 miles. But like I said, this is an overestimate.
So the last type of Riemann sum we will be showing you is MRAM, which uses the midpoint of each rectangle under the graph. And this is actually the most accurate way of estimating using Riemann sums because it doesn't overestimate or underestimate by that much. So we will start out by using the midpoint of this width, which is 1/2. So we draw a line from the graph down, and then we'll draw a rectangle like this because this is halfway to 1. Then we'll do the same thing with all the other ones. This is 1.5. Draw a rectangle like this. and then to 2.5. And then from 3.5, we'll draw a line down. So it's the same idea. Each rectangle has a width of 1, so we'll do the same thing we did before, because we're just finding the area of each rectangle using base times height. So the height for this is 5, so 1 times 5 is 5. Then the height for this is 15, which equals 15. Height for this one is 25, and the height for the last one is 35. So we add those up, and you get an approximation of 80 miles traveled in 4 minutes. And this is actually the most accurate, and is in between both the R-ram and the L-ram approximation.
Trapezoidal rule. Another way of estimating the area under a graph. However, this gives a more accurate estimation. Our first example using the trapezoidal rule is to find the area under the graph x squared. We are going to be doing so from 1 to 2. Here we have n equals 4. This means that we are going to be splitting this section up into 4 smaller subsections. As you can see, by doing so, we are going to be creating a new width for each of our sections, which is 1/4 or 0.25. The equation for the trapezoidal rule is pretty simple, but it looks complicated, so don't let it trick you. The equation is t equals h over 2 y0 plus 2y1 plus 2y2, and this continues on until your last y, but your last y will be not multiplied by 2, just like your first. H we have here is given by the equation y equals b minus a over n. B being your last point that you are trying to find, and a being your first. N is given to you, which we have here is 4. So, as you can see, b is 2, a is 1, and n is 4. So 2 minus 1 over 4, or 1/4. Putting this into the equation, we have 1/4 over 2, or 1/8 times y sub 0. So y sub 0 is going to be our 1 here, and we're going to be plugging this into the equation x squared, which is going to give us a 1 plus 2 times y sub 1. And so you're going to have to start plugging these numbers into the equation. So 1.25 squared is going to give us 25 over 16 plus 2 times 1.5 squared, which is going to be giving us 36 over 16 plus 2 times 49 over 16 plus, but remember the last point, you're not going to be multiplying by 2, so it's just going to be 2 squared, which is 4. When you solve the equation, you get 75 over 32, or 2.344. Thanks for struggling through that with me.
Okay, so this question is actually a little more difficult than the previous one Ethan showed us, because I will not be drawing the graph for you, so it might be harder for those of you that like to visualize your problems. So for this problem, our function is sine x, and we're given the information that n equals 2. So it's asking us to find the area under the curve of the sine graph from pi over 4 to 3 pi over 4. And we can do this by using the trapezoidal rule and estimating the integral. So first, we need to find our h value. And h, again, like Ethan said, h equals b minus a over n. Our b, in this case, is 3 pi over 4 minus pi over 4 over 2. And this equals pi over 4. So that's our h value. So if you were to draw a graph, that would be the width of each trapezoid that you would draw is pi over 4. So now we can plug this information into our trapezoidal rule formula. So we have t equals h over 2. So pi over 4 over 2 is just pi over 8. Times, then we're going to have f of pi over 4 plus 2 times f of pi over 2 plus f of 3 pi over 4. In this case, you can see only one of our y values is multiplied by 2 because we're only having 3 trapezoids, and our first and last won't be multiplied by 2. So if you plug pi over 4 into sine x, you get square root of 2 over 2 plus, if you plug in pi over 2 into sine x, you get 0 times 2 is still 0. And if you plug 3 pi over 4 into sine x, you also get square root of 2 over 2. So if you add those up and multiply by pi over 8, you get pi times the square root of 2 over 4 as an estimate by using the trapezoidal rule.
Our first second way problem is finding the area from 0 to 2 of the equation x squared. You're going to be using n equals 4 for this, and we want you to use the trapezoidal rule to estimate the area. We'll be right back with the solution. The answer to this problem is 2.75. If you got it right, congrats, but we're not going to give you anything.
Okay, our second send away problem is finding the area of the graph 1 over x from 1 to 3 using the information n equals 4, and we want you to use LRAM to estimate or use the left endpoints of the rectangles. So pause this video and try the problem. The answer to this problem is 1.28. So if you got it right, good job, but still not giving you anything. Thanks for watching our video. Hope it helped. It probably was more confusing than helpful, but
Just go ask Calc. He'll love your questions and he'll be super pumped to help you.
have fun!
Good luck.